Now we're going to look at the prime factorization method for finding GCD and LCM. And of course it's going to involve, well, prime factorization, where you do a factor tree and you write out a list of multiplication, all the prime numbers that would multiply together to equal your numbers. So the way that we do this for the GCD is you find the prime factorization, so do a factor tree, and then you identify the prime factors that are common to both. It's got to be common to both. And you multiply those common factors together, and that will be your GCD. So this is a very efficient way to go about finding GCD. So we'll start with factor trees. So like for 45, 45 is 9 times 5, and when I get to a prime number I circle it. And then 9 is 3 times 3. So I'll write it down over here. 45 is 3 times 3 times 5. I'll use dots for my multiplication here. 3 times 3 times 5. That's what 45 is. I'm going to do my work on this side. Then for 75, well, 75 is, well, it's 3 times 25. That works, right? And then 25 is 5 times 5. Lots of different factor trees you can use to come up with it. So 75 is going to be 3 times 5 times 5. You always want to put your factors in order from low to high. Also, this is going to make this go a lot easier. So then you go through, and the GCD just wants the common factors. So what do they have in common? Well, they have a 3 in common. They also have a 5 in common. And you multiply those together, and you get 15. So the greatest common divisor, the biggest number that will divide into both of these, is 15. So with the GCD, you only take the common factors. So you line them up, and then you circle the ones that are alike, and you keep those. That will be your GCD. Now to do the LCM, we're going to do something very, very similar. But we're not just going to keep the common factors, we're also going to get to keep the leftover factors. So it says find the prime factorization of each number. Okay, take each prime factor that occurs in either number. It just has to show up in one or the other. So that would include the common factors, but also the leftovers. And if you think that leftovers starts with the letter L, that'll help you remember that it goes with LCM. So let's find the LCM of 18 and 20. Using the prime factorization method. So again, factor trees is how we're going to start. So 18 is what? 2 times 9, and then 9 is 3 times 3. So I'll write this over here. 18 is 2 times 3 times 3. And then 20 is 2 times 10, and 10 is 2 times 5. Right? So 20 would be 2 times 2 times 5. And again, I don't like to use the exponents. I like to just like stretch it out like that on the side. So we've got our 2 factor trees. So we're going to look for what's common, right? The ones that are common. The only one that's common is this one. There's a 2 that's common. So we're definitely going to take that because it's common. But then we also get to pull in any leftovers. As long as they show up at least once, they get to be in the LCM. So the LCM is a little more forgiving, and it will take all of the leftovers, and all these little guys are leftovers. So we have 3 times 3 times 2 times 5. So this is common, and leftover. And what we're going to do is we're going to multiply all of this together. And if you can't multiply it in your head, you could just use a calculator. But you're going to get, when you multiply all of that up, you're going to get 180. And so the LCM, the first multiple that they have in common, the smallest multiple that 18 and 20 have in common, is 180. That's the first one. So GCD, you just take the common factors. LCM, you take the common factors and any leftovers. So let's try one more here. We'll kind of put it all together. Oh my gosh, I've got papers everywhere. All right, here we go. Find the GCD of 60 and 75 and the LCM of 60 and 75. So we're going to find both all at the same time. So we're going to start by doing factor trees. For 60, let's do 6 and 10. 6 is 2 times 3. 10 is 2 times 5. So there's my factor tree for 60. 75, we've already done this factor tree already. So it's 3 times 25. And 25 is 5 times 5. Okay, so let me write it out. I like to kind of stack them up vertically. So I have 2 times 2 times 3 times 5. That's for 60. And then for 75, I have, well, I'm going to write it over here so that they line up a little bit better. 75 is 3 times 5 times 5. So if I stack it up like that, it makes it a little easier to find what's common. So let's see, what's common? 3 and 5. 3 and 5 is common. That's 15. That would be the GCD. So the GCD is going to be 15. Okay. I'll write it there. That's your GCD. The LCM is going to be the common ones, so the 3 and the 5. But also, remember, it takes the leftovers. So it takes the 2 and the 2 and the 5. Those are the leftovers. Just making some notes here. These were common. But if you take the common and the leftovers, you get the LCM. If you multiply all of this together, that's 15 times 20, basically. You get 300. And that is your LCM. So I'll say 300 up there. So there we used one method and we were able to get both. Common factors make up your GCD. The common factors and any leftovers make up your LCM.